welcome back everyone. Today we are going to start chapter number 4. So chapter number 4 is pair of linear equation in two variables. So here we can see pair means 2, right? Pair means 2. And here we have two variables. What is variable? An alphabet which can a number be replaced with, right? And a variable means x, y, z, p, q, any alphabet we can take. So now we have two variables in this chapter, right? Here we have linear equation. So what is a linear equation? Equation in the form of ax plus by plus c equals to 0, right? Equation in the form of ax plus by plus c equals to 0, where we have here a, b, c, right? Now we should define these alphabets also. A, comma, b, comma, c belongs to real numbers. So a, b, c are real numbers, and a, b, c are real numbers, and here we have a and b. So we should specify a and b. A square plus b square will not be equals to 0. A square and b square will not be equals to 0 and will not be equals to 0. This type of equation is called linear equation. Linear equation, we have two variables x and y, so therefore we write in two variables. So this is the definition. So this should be remembered. So we have to remember that a, b, c are real numbers, x and y are two variables here, and which is the standard form ax plus by plus c. What was for the polynomial ax square plus bx plus c equals to 0 was for the polynomial, but here we have ax plus by plus c. This is for polynomial, quadratic polynomial. It is for linear equation. We have pair. Pair means two equations. So let us take two equations now. That is a1x plus b1y plus c1 equals to 0. a2x plus b2y plus c2 equals to 0. Okay. Now here a1, b1, c1, a2, b2, c2. These 6 are real numbers. a1 comma a2 comma b1 comma b2 comma c1 comma c2 belong to real numbers. Okay, and a1 square plus b1 square will not be equals to 0. a2 square plus b2 square will not be equals to 0. So this, if this pair of equations satisfy these two conditions, then it is a pair of linear equations. Okay. Now if these two are equations, right, they will be equal at some point x and y. So we should find the point x and y where these two will be equal. These two will intersect, or we know it as 0 of these lines. Okay, 0 of these equations. So now for finding it, we have three methods. First one is graphical method, so by graph. Second is substitution, and third one is elimination. Elimination method. Okay, we have three methods. First one is graphical method, second one is substitution method, third one is elimination method. So before doing this all, we can easily find how many solutions this pair of equations have, this pair of linear equations have. So first let us see how we can find how many solutions and what type of lines these are. So we have here a1, a2, b1, b2, c1, c2. So here these three are alphabetical words. So by using these three only, we will do something. What we can do? A1 by A2, B1 by B2, C1 by C2. Okay. Now here, if A1 by A2 is not equals to B1 by B1 by B2. If A1 by A2 is not equals to B1 by B2, leave about C1 by C2. Then what it will be? Means these lines are consistent. These lines are consistent and have one unique solution. Means they have only one pair of x and y. Means they have a unique number for it, 5 or 7 or 7 or 5, 49 or 50, something. Only one will get. We'll get only one x and one y. If a1 by a2 equals to b1 by b2 not equals to c1 by c2, not equals to c1 by c2, then what we'll get? Inconsistent. Means lines are inconsistent and we will get no solution. No solution. Next, a1 by a2 equals to b1 by b2 equals to c1 by c2. Lines are consistent. Lines are consistent. Infinite solutions. Infinite solutions means many solutions. Unlimited solutions, infinite solutions, everything. Infinite solution. So here you see a1 by a2 b is not equals to b1 by b2. So lines will be intersecting. Lines will be intersecting like this. Intersecting. This is the point of intersection, right? Here inconsistent and no solution means lines are parallel. Lines are parallel. Third one, infinite solutions means lines are coincident. Lines are coincident, which means they are one above the other. They are one above the other. They are one above the other, so they have many solutions, infinite solutions. So in this, by doing a1 by a2, b1 by b2, by checking this, we can find how many solutions this pair of linear equations have. We are starting exercise 4.1, first bit. By comparing the ratios a1 by a2, b1 by b2, c1 by c2, state whether the lines represented by the following pairs of linear equation intersect at a point, are parallel or coincident. So what we have done, a1 by a2, b1 by b2, c1 by c2, we have learned now only. So let us do that. So what is the value of a1 here? a1 equals to 5, a2 equals to 7, a2 equals to 7, a1 equals to 5, right? So b1 equals to 4 minus 4, here we have minus sign. So c1 equals to 8, b2 equals to 6, c2 equals to minus 9. Okay, now a1 by a2, that will be equals to 5 by 7, b1 by b2, that will be equals to minus 4 by 6, c1 by c2, that will be equals to 8 by minus 9. So r a1 by a2 equals to b1 by b2. So let us solve. 2 2s are 2 3 times. So minus 2 by 3. Therefore a1 by a2 not equals to b1 by b2. For intersect at a point. Intersect at a point, or unique solution you can write. Unique solution, because a1 by a2 not equals to b1 by b2. a1 by a2 is 5 by 7, b1 by b2 is minus 2 by 3. So therefore the pair of linear equations will intersect at a point or have a unique solution. In the second one, we have 9x plus 3y plus 12 equals to 0 and 18x plus 65 plus 24 equals to 0. Now a1, what we have, coefficient of x, that will be 9. a1 will be 9. a1 will be 9. b1 equals to coefficient of x, sorry, coefficient of y, that will be equals to 3, and c1 equals to constant, that is 12. a2, coefficient of another x, that will be equals to 18. b2, coefficient of y, that will be equals to 6. c2 equals to 24. Now a1 by a2, that will be equals to 9 by 18. So 9 ones are 9 twos are 1 by 2. b1 by b2, 3 by 6. So 3 ones are 3 twos are 1 by 2. c1 by c2, 12 by 24. 12 ones are 12 twos are, that is also equals to 1 by 2. Therefore a1 by a2 equals to b1 by b2 equals to c1 by c2, right? a1 by a2 equals to b1 by b2 equals to c1 by c2. So lines are coincident. Lines are coincident and have infinite solutions. And have infinite solutions. Now we have been given 6x minus 3y plus 10 equals to 0, 2x minus y plus 9 equals to 0. So a1 equals to coefficient of x, that will be equals to 6. b1 equals to coefficient of y, that is minus 3. c1 equals to constant, that is 10. a2 equals to coefficient of x, that is equals to 2. b2 equals to coefficient of y, that is minus 1. c2 equals to constant 9, that is 9, right? So here we have only minus 5. Minus 5, if we have been not given a number, so minus 1 into y, that is minus 1. Okay, what answer will be? It will be minus y only, but here we get the number 1, coefficient as 1. So always if we don't get a number before of coefficient, always take as 1. So now a1 by a2 equals to 6 by 2, that is 2 1. 2 1 times 6 3 times, right? 2 ones are 2 threes are, so 3. b1 by b2 equals to minus 3 by minus 1. Minus minus get cancelled, answer is 3. Now c1 by c2 equals to 10 by 9. So we can't divide it. So therefore a1 by a2 equals to b1 by b2 not equals to c1 by c2. What it is? It is parallel. Lines are parallel. Okay. Now exercise 4.1 second bit. Check whether the following equations are consistent or inconsistent. Solve them graphically. So we have to check the equation, the pair of equations are consistent or inconsistent, and we should solve them graphically, not by substitution method or elimination method. So first let us write a1 by a2, b1 by b2. Okay. Now a1, what is a1? Coefficient of x, that is 3. b1 equals to coefficient of y, that is 2. c1 equals to constant. Constant, if the constant goes left side, it will become minus 5, right? If this constant goes left side, it will become minus 5, right? So now a2 equals to coefficient of x, 2. b2 equals to coefficient of y, minus 3. c2 equals to constant. If this goes left side, that will be minus 7. So now a1 by a2 equals to 3 by 2. b1 by b2 equals to 2 by minus 3. So therefore here only we can say that a1 by a2 not equals to b1 by b2. Therefore it will have an unique solution, right? It will have an unique solution. Now we have to solve these equations. Now we have to solve these equations. Now this pair of equations, these equations are consistent, right? They are consistent. Now 3x plus 2y equals to 5. 3x plus 2y equals to 5. Now we have to take x value and y value and x comma y. So what value of x we will take and what value of y we will take, that will be equals to 5. So in the place of x we can write 1. 3 into 1 will be 3, and how much is remaining? 2, right? So y value also will be 2. What will be the x and y value? 1 comma 1. So if you substitute, 3 into 1 plus 2 into 1 equals to 5. 3 plus 2 equals to 5. 5 equals to 5. So LHS equals to RHS. So this pair of x and y satisfies. Now next, 3 into 3, 9. So 3 into 3, 9. Now we have to subtract 5 out of it. How much we will get? So 3 into 3 will be 9. So we have to get 5. So 9 minus 4 will be 5, right? 9 minus 4 will be 5. So 2 into 2 will be plus 4. 2 into 2 will be plus 4. 2 into minus 2 will be minus 4. 2 into minus 2 will be minus 4. So we'll take minus 2 here. So what it will be? 3 comma minus 2. Now if you substitute this 2 in this equation, what you will get? 3 into 3 plus 2 into minus 2 equals to 5, right? 3 3s are 9. 9, 2 into minus 2, minus 4. 9 minus 4 will be 5. LHS equals to RHS. LHS equals to RHS satisfied, right? So here you see 9 minus 4 equals to 5. 5 equals to 5. So second equation, 2x minus 3y equals to 7. So now x, y, x comma y. So 2 into 5 will be 10, right? 2 into 5 will be 10. So 10 minus 3 would be 7. So y value would be 1. How? Here you see. Here we'll do 2 into 5 minus 3 into 1. 2 5s are 10. 10 minus 3 equals to 7. So 5 comma 1. Okay. Now next what we can do? 2 2s are 4 and 3 1s are 3. It will be 7. So 2 into 2 minus 3 into minus 1. 4 plus 3 equals to 7. So 2 into 2 times, that will be x value will be 2 and y value will be minus 1. We are taking minus 1 because we have minus sign before 3. So 2 comma minus 1. 2 comma minus 1. So these are the 2 points which are useful for us in pointing the graph. Okay, now let us point the graph. Now this is the graph. We have y-axis here, we have x-axis here, right? So now what are the points we have got is 3 comma 2, 1 comma 1, 5 comma 1 and 2 comma minus 1. So all are within 5 only. Okay, so what will be the scale? So you have to write scale always. Scale, x-axis 1 unit equals to 1 centimeter. Y-axis 1 unit equals to 1 centimeter. Okay, now this is the origin 0, 1, 2, 3, 4, 5, 6, 7, 8, and on the left side negative minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Now above we get positive 1, 2, 3, 4, 5, 6, 7, 8, 9, and below we get minus negative minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10, minus 11. Now what are the points to be plotted? So here it is 1 comma 1. So 1 comma 1 it is here, right? 1 comma 1. Next we have 3 comma minus 2, 3 comma minus 2, y is minus 2, so here minus 2, x is 3, y is minus 2, 3 comma minus 2. Now this is the line 3x plus 2y equals to 5. So draw a straight line. Always draw a straight line. So this is the line 3x plus 2y equals to 5. So draw the arrows. Next we have 5 comma 1, 5 comma 1. So 5 comma 1, it is here. And another we have 2 comma minus 1, 2 comma minus 1. So there, here you can see. Here this is the intersecting point. We have drawn the lines. Here you get the intersecting point, that is 29 by 13 comma minus 11 by 13, right? 29 by 13 minus 11 by 13. So now you will say, sir, how you got this? So I will show you. I'll show you here. See, if you solve these two, 3x plus 2y equals to 5, 3x plus 2y equals to 5, and 2x minus 3y equals to 7, right? So I'll show you on the board. We have seen on the graph that these lines are intersecting somewhat like here, right? Somewhat between 2, 1 and 0, 0 and 1. So these lines are intersecting here, and the intersecting point I said was 29 by 13 and minus 11 by 13, right? 29 by 13 and minus 11 by 13. So how I got? So if you see in the graph, we can't exactly say that these are the points 29 by 13 or minus 11 by 13, because we only have 10 lines, 10 sublines in that, right? So now we have been given two equations, 3x plus 2y equals to 5 and 2x minus 3y equals to 7. So now by substituting method we will do that, or we will directly solve these equations. So here x, we have to equate the value of x, right? So we will multiply this into 3, this will multiply into 2, because the coefficient of this equation is 3, so we are multiplying another equation by 3. Here we have 2, that's why we are multiplying by 2 upside. So what will be the equations then? 6x plus 4y equals to 10, 6x minus 9y equals to 21. So subtract plus subtract, change the signs. What you will get? This 6x will get cancelled. So plus 9y plus 4y, that will be 13y equals to minus 11. So y equals to minus 11 by 13. So what were the points we got? X equals to 29 by 13, y equals to minus 11 by 13. So we got the y value, right? Next, what we have to do, we have to find the x value. So substitute this y value in any of the equation here. So 6x plus 4 into minus 11 by 13 equals to 10. Okay, so 6x minus 44 by 13 equals to 10. So this 13 into 6, 13 6 are 78x minus 44 equals to 130. This 13 will go in 13 into 10, 130. So 78x equals to 130 plus 44. This 44 will go to RHS, minus 44 will go to RHS, and it will become plus 44. So it will be 174. So x equals to 174 by 78. So now 2 3s are 6, 2 9s are 18, 2 8s are 16, 2 7s are 14. So again 3 1s are 3 3s are 3 2s are 6, and 3 9s are 27. So it is 29 by 13 here. Okay, so we got the x value, y value. So somewhat you have to do substitution method in graphical method also to easily find the x and y. So if you point the graph, you can't exactly say that this point is that. You can't exactly calculate the value of x and y. So you have to solve that graphically first you have to solve that in this way, and you can show that this value of x equals to 29 by 13 and y equals to minus 11 by 13. So it will be easy for you. So in the next video we will do the other problems of exercise 4.1. Thank you.